Alright, so here's the second problem. We're going to want to find the open interval where the function is increasing and decreasing and relative extrema. Okay, so first thing we do, we want to find the critical numbers. So remember, to find critical numbers, you find the first derivative. So here we have to use the chain rule. That's going to be 2/3 times x squared minus 4 to the negative 1/3 times the derivative of what's inside the parentheses, so times 2x. Okay, so now let's rewrite this. Let's make it look a little better so we can solve it. So that's going to be 4x over 3 over 3 times x squared minus 4 to the positive 1/3. Alright, so remember the critical numbers, that's where the first derivative is equal to 0 and where it's undefined, so long as wherever the first derivative is undefined, those numbers are also in the domain of the function. Alright, so we set the first derivative equal to 0 and solve for x. Well, we know when we're dealing with a fraction, the only time a fraction is 0 is when the numerator is 0. So all we have to do is set the numerator equal to 0 and solve, so we get x equal 0. And then we also want to know where it's undefined. Well, it's undefined where this denominator is 0. So I'll take the denominator, x squared minus 4 equals 0. I don't need the 1/3 because all we need to know is when this inside the parentheses is 0, because 0 to the 1/3 is 0. Alright, so if I solve it, I get x squared equals 4, x equal plus or minus 2. Alright, so now that we found our critical numbers, and the plus and minus 2, those are critical numbers because that's where the first derivative is undefined, but plus and minus 2 is also in the domain of the function. Alright, so now we take our critical numbers and we plot them on a number line. So I've got -2, 0, and +2. And this breaks the number line up into 4 regions. So what we need to do now is pick a number from each one of these regions. Okay, so here I'll choose x equal -3. Here I'll choose -1. This region I'll choose 1. And this region I'll choose 3. And remember, you can choose any numbers you want as long as you choose a number from each region. Okay, so now I need to take each one of these numbers and plug them into the derivative. I'm going to plug them into this one. So if I take f prime of -3, okay, so I'm going to plug it in, and I don't care what the exact number is. All I want to know is when I plug the -3 into the derivative, do I get a positive or negative answer? Well, if I plug the -3 in, 4 times -3 is negative. If I plug the -3 down here, that's going to be 9 minus 4. That's positive. Okay, so in the numerator I'll have a negative, denominator I'll have a positive. So a negative over a positive, that's negative, so that's less than 0. So since it's negative, that means on this interval our function is decreasing. Okay, now let's do the same thing with the -1. So I've got f of -1. So when I plug the -1 in, that's going to be a negative in the numerator. 4 times -1 is -4. And if I plug it in down here, -1 squared is 1. 1 minus 4 is -3. So this is negative The 3 is positive, of course. So I'm going to have a negative over a negative, which is positive, so that's greater than 0. So that means on this interval it's increasing. And then we'll do the same thing with 1. F prime of 1, that's going to be a positive and a negative down here. So that's negative, so that's less than 0. So that means it's decreasing. And then for the x equal 3, that should be a f prime there. F prime of 3, that's going to be positive. This will be positive down here. So that's greater than 0. And so that means on this interval it is increasing. Alright. So now we can see that this thing is increasing on the intervals here, -2 to 0, and here, that's 2 to infinity. And it is decreasing here from -infinity to -2, and decreasing here from 0 to 2. Okay? And so there's your solutions for increasing and decreasing. Now let's look at our relative extrema, find relative max and mins. Alright, so if we look at this, we can see that it's increasing and then it starts, it's decreasing and then it starts increasing. It decreases until it gets to -2, and then when it gets to -2 it starts increasing again. And also over here it's decreasing, and then at 2 it starts increasing. So here we have a relative min, and at 2 we have a relative min, and then at 0 you can see here we have a relative maximum. Okay, because it's increasing and then it decreases. It increases until it gets to x equals 0, and then it starts decreasing at x equals 0. So we have a relative minimum at the point. Our first point is at -2, and then we need the y value. So to get that, I'm going to go ahead and erase this so I can have some room. Alright, so to find our y value here, we take the -2 and plug it back into the original function. So that's going to be f of -2 is equal to -2 squared minus 4, and then all of that raised to the 2/3. Okay, so this is going to be 4 minus 4 is 0, so that's going to give us 0. And we have a relative min here at x equal 2. And if we plug 2 in, +2 into the function, we're going to get 0 again. I'm not going to go through and show that. Okay, and then we have a relative maximum at x equals 0. So to find our y coordinate, we take the 0 and plug it in. So f of 0 is equal to 0 squared minus 4 to the 2/3. And so that's going to be -4 raised to the 2/3. And we can just leave it like that. So that's going to be -4 to the 2/3. Okay, and so this would be your relative max. So hopefully this video helped. Don't forget to like and subscribe. All right, thanks.